স্ক্রিন দেখা যাচ্ছে? Is the screen visible?
হুম
হুম
Okay. So how do we create a Mobius strip? So suppose assume this is a rectangle. I mean this is a rectangle. You don't have to assume that. So what will we do? We will attach this side. We will glue this side with this side, but with reverse orientation, right? Like this point will be attached to this point. This point will be attached to this point. The point here will be attached to the point there. Okay. So what we do? First we just twist it. Okay. And then okay. So this is your Mobius strip, right? Right? That's the Mobius strip. Okay. Now there are few things you need to notice. First, what is the boundary of the Mobius strip? Again, let's open it. So you see, this end and this end was glued together. Okay. So the boundary is basically this and this. I mean, I'd like to say the boundary is this union this after the operation that we were just doing to make the Mobius strip, right? Because you see, these sides, these two vertical sides, they are actually glued together. Okay. Now, to see the boundary, you see we start from this point. Okay. Okay. And you see what we are doing. You see, we have come back here. Okay. So watch it again. This,
একটু ওপরে তোল করো স্ক্রিনের বাইরে হ্যাঁ
this. We will move along the boundary. Okay. Move along the vertical sides. I mean the vertical sides of the rectangle. This. Okay. This is going inside. Coming back to this side. Here. Okay. So basically, it's a circle. It is a circle. Okay. The boundary of the Mobius strip is a circle because it is a closed curve without any self intersection. That is clear. So that was for the Mobius strip. Now, how do you make a cylinder? Again, you take this rectangle and you glue this side with this side. The vertical sides you glue like this. Okay. So this is your cylinder. I mean, not exactly. This is your cylinder. Okay. Now, if you even glue these two sides, you get a torus, right? So let me draw the picture. This is the Mobius. this is your Mobius strip. Okay. What about the cylinder?
এই স্ক্রিনটা চেঞ্জ করতে হবে তোমার।
Hmm. You can see the board. Can you see the board?
Yeah.
So how the cylinder will look like? You see, I mean this black parts means this will be glued to this. Okay. Now what about the cylinder? So you have, suppose, or maybe I should use the usual. Okay. By the same arrow we mean these two will be. So for Mobius strip our picture would have been this, this and this. Okay. So this side will be attached to this side but with reverse orientation, I mean with reverse direction. But here we have, maybe should write like this. Okay. So this side. Okay. So you see how different it is. Both we are making, I mean in each of the cases we are gluing the vertical sides with each other of a rectangle. But what we are doing is that sort of we are what should I say, we are gluing them in the opposite direction here and so in the same direction here. Okay. So what will it be? The pi map, it will be like, right, you just roll it and this is the joining boundary line. Okay. Now what will be your torus? What will be your torus? So torus is nothing but, so first you make a cylinder. Okay. Okay. And then join these two vertical sides this way. So the same arrow with the same direction. Okay. That's how you glue it. Understood? That's how you glue it. So basically what do you get is that first you make a cylinder like before. This is the line of joining and you already have this. Okay. Now, so what do you have now? You have this, or maybe a donut biscuit, right? That's it. Where your joinings are, so one is this along, I mean maybe here, and another joining is here, right? Okay. So this is a torus. Okay. see, we will try to write everything in a proper way. Let's try to see what we are doing right now. What about a client's bottle? Okay, so first, Rahul was sure actually. This will be our lecture 0. So what is the goal?
Hmm.
What is the goal of this topic? So maybe I should write this thing here. This is lecture 0. What is our goal? Long term goal. So quotient topology and identification topology, this is for interview. I mean, for interview purpose, this is fine. I mean, this is still interview. Interview is covered in this. Okay, your PhD interview. The long term goal is algebraic topology slash differential. So how do we make lines bottle? So first again you make a cylinder. Okay, observe it. So the first step is a cylinder. Okay, in the second step, remember, so the horizontal side will be glued, but they will be glued in the reverse manner. Clear? So again this will be like a cylinder first, then I believe it is impossible for me to draw. Okay, so the client's bottle look like, I mean, I'm afraid I'm not very good at drawing pictures, so just let's find out. My mom here is laughing because I was almost 10 years in a drawing class, and the teacher is also very close to me, but he never introduces me to to others, saying that I am his student. He says I am his relative and something like that, because I was just too bad. Let me get a, yeah, this is, you understand what they are doing. So you see, this is a cylinder, okay? That's fine. Hello. হুম, বলছি ক্লাস চলছে তোদের, রাতের দিকে কল করা যাবে না? বা তুই কাল সকালে ফ্রি আছিস 1:30-2:00 দিকে, 1:00-2:15 দিকে? তাহলে কালকেই কথা হবে 1:00-15 দিকে, ঠিক আছে? বেশ। Okay. So can you tell me how can I take this screenshot? Mm, Uh,
স্নিপিং টুল বলে টাইপ করো,
hmm?
তাহলেই পেয়ে যাবে। স্নিপিং টুল বলে তোমার নিজের মানে এই স্টার্ট বাটনের সামনেই টাইপ করো না।
বা ওপরে তুমি ওই অ্যাপের ওই ড্রাইভেও বোধহয় করতে পারো। ডাইরেক্ট
I was going for Control Shift S, but it didn't work. No, I'm afraid there is not something. This is probably.
না, না, এই তো এসে গেছে ওপরের অ্যাপটা দেখো। হুম, এটা সিস্টেম অ্যাপ তোমার।
So clearly you can see the tremendous speed of this computer actually. Here keyboard. কি হচ্ছে?
ওটা আনোয়ার কি লিখছে দেখো, উইন্ডোজ প্লাস শিফট প্লাস
Windows plus what?
উইন্ডোজ প্লাস শিফট প্লাস এস।
আচ্ছা, Windows plus Shift plus F. বাকি কিছু তো
হওয়ার কথা, এটা তো হচ্ছে।
হচ্ছে না কিছু আমার।
একটু দেরি হচ্ছে বোধ হয়। হুম।
না, না, এই কিগুলো মাঝে মাঝে কাজ করে না,
হ্যাঁ,
এই শর্টকাট কিগুলো। সেই জন্যই এই অ্যাপটা তুমি ইউজ করো। এই ওখানে ক্লিক করে দেখো অ্যাপের ভেতরে।
Okay, so okay, just do one thing please. Send me a screenshot of this thing. I will just copy paste it. Okay. Otherwise, it's gonna take forever. Please, someone just do this. Do it for me.
কেউ পাঠাচ্ছি?
তুই কি করলি?
না, আমি তো এখনো পাঠাচ্ছি না।
বা তোমার কি ওই ইয়েটা রয়েছে ওপরে, কি বলে ওই, কি বলে অ্যাটাচমেন্টস এ দেখো ওই ওপরে একদম ওই একটা ওই পাজল টাইপের একটা ছবি আছে তোমার লেট স্টাডি লোগোটার পাশে। ওইটা কি ড্রাইভের এটা রয়েছে ড্রাইভের
হুম,
ওই পাশে দেখো পাজলের একটা এর মতো।
হুম। ড্রাইভে যাবো? Should I go to the drive?
এইটার, হ্যাঁ ড্রাইভটা এটা ক্লিক করো দেখো আমার এখানে, কারণ এই এক্সটেনশন একটা রয়েছে যেটা ডাইরেক্ট এটা ক্লিক করলেই আমার স্ক্রিনশট হয়ে যায় জিনিসটা, মানে পেজটা।
না না, আমার ওই ইয়েতে চলে যাবে,
ক্লিক
ড্রাইভে
করে
চলে
দেখ।
যাবে।
আচ্ছা
না,
আচ্ছা,
no no, we are wasting time.
এই অ্যাটাচমেন্ট কয়েকটা ওই ডাউনলোড করে রাখতে পারো, এক্সটেনশন কয়েকটা ডাউনলোড করে রাখতে পারো, সেভ টু গুগল ড্রাইভ বলে একটা এক্সটেনশন হয়, ওটা ডাউনলোড করে রাখতে পারো, এক মানে ওই 1 MB হয়তো, তোগুলো ডাইরেক্ট হয়ে যায়।
আমি বলছি কোনোভাবে কি ইয়েটা জাস্ট এইটুকু পাঠানো সম্ভব? মানে what I'm trying to say is that only this part, I only need this.
মানে ছবিটা তো,
Hmm.
আচ্ছা
Only this.
মানে ছবিটা তো সেই ওই স্ক্রিনশট না হলে এখান থেকে তারা স্ক্রিনশট করে দিয়ে দিচ্ছে আপাতত। এটাই ডাউনলোডও করতে পারো তো।
No.
গিয়ে ক্লিক করলে ডাউনলোড হয়ে
Yes,
যাবে মনে
yes,
হয়, দেখো।
yes, 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 done. Okay, so clearly you can see there is a self intersection, right? I mean, in 3D, if you join it, in 3D, if you join it, I mean, that cylinder has to go within itself, right? Look at this part. Look at this part. This part. The cylinder is going within itself, right? To reach that opposite end.
জয়দীপ স্যার আবার কি সব লিখছে? এই দাদা কি লিখেছে দেখ।
ভাবছিলাম যে he will be writing something. সবাই বাঙালি এখানে।
একদম।
আমার রিপ্লাইটা দেখ। মুশকিলটা এই গ্রুপে বাচ্চা কাচ্চা নেই তো, সেটাই ভয়ের।
না সবাই 18 পেরিয়ে গেছে আর কি।
Still,
এই বিকেলবেলায় আমি ভুল করে এই গ্রুপে একটা স্টিকার পাঠিয়ে দিয়েছি ভুলভাবে। আমি দেখিনি যে তুমি এই গ্রুপে এইসব স্টিকার পাঠাচ্ছ বলে।
অর্পণের রিপ্লাইটা দেখ, দ্যাটস ওয়াই আই সেন্ট ইট।
কোথায়
না অর্পণ খেলে গেছে বিরাট। ও এক ঘর রিপ্লাই করেছে ওটা।
এই রিপ্লাই গুলো কোথায় আসছে? আমি তো দেখতে পাচ্ছি না। ফিল্ড এক্সটেনশন গ্রুপে খালি জয়দীপ সাহার দুটো কমেন্ট দেখছি।
যারা এই ভিডিওটা ইউটিউবে দেখবে তাদের কাছে পুরো জিনিসটা সাসপেন্সে চলেছে।
পাঠালাম।
আসলে ক্লাইন্ট বোটলে কোনো লিকুইড ধরে রাখা যায় না, এই সন্ধ্যাবেলা লিকুইড ধরা যায় এমন বোতল কোনো সাহস পাঠাও। কোন সাহসে পাঠাও? আমাদের এসএস স্যার। এই রিপোর্টটা কেটে দিও, বাই চান্স যদি কোনোদিন পিএইচডি পেয়ে যাদবপুরে যদি কোনোদিন ঢুকতে যাই ফ্যাকাল্টি হয়ে, স্বপ্ন দেখতে ভালো লাগে।
দেখ, okay, I will want to send you one thing. You will definitely complete your PhD and still you will definitely be unemployed. So your status will
সেটা
improve. Right now you are unemployed with an MSc. So soon you will become an unemployed with a PhD, then you will become an unemployed with a postdoc, and so on.
ওই মানে সিঁড়ি আছে কিন্তু ফ্লোর নেই।
Oh, that's good one. Okay, fine. So this is a Klein's bottle. Okay, we spent almost half of the class just to look for a proper picture. So you can understand how difficult it is to embed it in R4 or even R3. Now, what do I mean by embedding and all that? We will move on to the rigorous definitions. Just a moment. So this was Klein's bottle. Another thing is there. Oh, RP2 is there. Okay, RP2 is there. Again,
এই স্ল্যাশের বদলে অর লিখে দাও না।
real projective plane. Okay. So, by the way, this will be a serious class. Okay. This is my forte. So I'm not gonna just look around and scratch around for materials. RP2 or P2, real projective plane. So what we do that? For the time being, we are not taking a square. We are taking okay, and the identification is we will join the antipodal points. Okay, so every x belongs to S2 will be glued to minus x, that is antipodals are identified. Again, the struggle begins.
এটা পাওয়া খুব চাপ আছে।
Real projective plane. Yes. ভয়ঙ্কর জিনিসটা। Yes, this is good. This look like an antenna. Subrita, please give me a screenshot of this thing. Okay, just a picture. This thing, just give me a picture.
আরেকবার দেখাও।
This one, which looks like an antenna. Okay.
এই পাঠিয়ে দিয়েছি, ডিরেক্ট ইমেজটাই পাঠিয়ে দিয়েছি।
Okay. Now see, these are sort of hand wavings. Okay, we are gluing this, we are doing that, we are doing those, but I mean, we have to make things rigorous. The first of the thing is that what are the topologies? Because you see, I mean, so the basic question is how to define a topology on the new figures.
আচ্ছা হ্যালো,
Yeah.
বলছি তার আগে একটা জিজ্ঞেস করছি, এরকম শেপটা এটা একটু বুঝিয়ে দেবে, কারণ এই কনস্ট্রাকশনটা দেখে মনে হচ্ছে হেমিস্ফিয়ারের মতো হবে, কারণ
No,
অ্যান্টিপোড
that
গুলো
won't
যেসব।
be. That won't be. I mean, because there is again, what sort of, how can I say that? Wait a minute. How can we embed them in some Rn? So first of all, you see the problem is that so first you do this. Okay. Okay. And you keep the boundary here. Understood? You keep the boundary here. I mean, I have taken out this circle apart, I mean, from outside of sort of S2.
আচ্ছা,
So clearly these two will be identified with each other, right? These
হ্যাঁ,
two will be identified with each other and they will make one, because they will be like this. Let me again. So video download. So suppose this was S2, right? This is S2 and this is the boundary. Not exactly boundary, the, what should I say, the equator. So I have taken out the equator. Now I have two hemispheres. So they will be joined like this. Okay, in the reverse direction.
আচ্ছা, হ্যাঁ,
But the problem here is the main problem will be, I mean, how to, but again you will have to rejoin the equator.
হ্যাঁ, মানে ওটা ডিস্কের মতো হয়ে যাবে, তাই তো? ওই ওপর আর নিচটা মিলে একটা ওপেন ডিস্কের মতো হয়ে যাবে।
No, it won't be an open disk. Yeah, like an open disk. Like an open disk. Okay, we will move on to that definition as well. There are alternative three definitions of RP2. Okay, we will
আচ্ছা,
see through them. Hello, আমরা কোশ্চেন টোপোলজি শুরু করেছি আজ থেকে, তুমি চাইলে জয়েন করি, সেই কারণে বলছিলাম। হুম, হ্যাঁ, এখনো চলছে তো, এটাকে জাস্ট লেকচার জিরো, এটাকে লেকচার জিরো বলছি, তুই আজকের ক্লাসটা দেখে নিয়ে জয়েন করিস, ঠিক আছে? ঠিক আছে। হুম হুম। Okay, so the main problem will be how that equator is, how the equator is identified, how the antipodals of the equator is identified in a way which is consistent with the first identification, that is this. Okay. So first of all, it's impossible to visualize RP2. Okay. Because this is
আচ্ছা
not in RP, no, not in C. In a way you can visualize it, but again. So just a minute. So let me move on to
হ্যাঁ
the rigorous definitions of these figures. Okay. So what do we mean by this sort of identification? What do you mean by gluing? So what is gluing mathematically? So let's define a few things. So first of all, move on to identification topology. So first we take X be a topological space. Okay. So be a partition on X. So you all know what a partition means. You know what a partition means?
Yeah, yeah.
So by partition we mean, so basically P is a collection of xi, I running from I belongs to capital I maybe, where each xi is a subset of x and xi intersection xj is phi and xi union is x. So basically if you union x all those xi's you get x, but they are disjoint and all that. Okay. So define an equivalence relation on x with respect to p, that is x y belongs to x are said to be related y, this is the sign, if x y belongs to for same for some I mean they have to belong to some particular xi. Okay. So check that is indeed an equivalence relation. define x tilde. What is x tilde? Maybe you can say like this. Is an equivalence class containing the element. So basically this is the set of all equivalence classes. Okay, set of all equivalence classes of. Okay, so basically we have partitioned X. Now we are considering only the equivalence classes. Understood? So this is clear.
Yeah.
That is, each xi corresponds to the বল। কত চাইছে? এটা বলা খুব মুশকিল, এটা বলা খুব মুশকিল, জানিস তো সুমন এখন ডিউটিতে রয়েছে হয়তো। এখন নিয়ে গিয়ে তো লাভ নেই, এখন তো আর সুমনদা নেই না, সুমনদা সকালে ওখানে থাকে, বিকেলে যায় এখানে। সেখানে নিয়ে যেতে পারিস, সেখানে নিয়ে যেতে পারিস, তারা লোক ঠকায় না, তারা লোক ঠকায় না। একটা কাজ কর, ওখানে নিয়ে যা, এটা তো আমি আইডিয়া দিচ্ছি, ঠিক আছে? ওখানে নিয়ে যা, নিয়ে স্বর্ণবিন্দু ব্যানার্জিকে খোঁজ। স্বর্ণবিন্দু ব্যানার্জি, ডাক্তারের নামটা দিয়ে দিচ্ছি আমি, উনি ওখানে সাথে অ্যাসোসিয়েটেড। ঠিক আছে, আমার ক্লাস চলছে, বুঝলি? এবার নামটা দিয়ে দিচ্ছি, ওখানে গিয়ে ওনাকে খোঁজ। এটা ভালো আইডিয়া, এটা 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 ভালো আইডিয়া। আর স্বর্ণবিন্দু ব্যানার্জি ইজ দ্য বেস্ট ইন দ্য বিজনেস, হ্যাঁ, তিনি আমার বাবাকে ট্রিট করছেন। ঠিক আছে, রাখছি রাখছি, তো নামটা ঠিক। So you see what we are doing is that, check that is indeed an equivalence relation, and x's are the equivalence classes. So what do you have? So for each xi it will correspond to some class which is represented by this small xi in capital Xi. Okay, so sort of you are treating each xi as a point, sort of you are treating each xi as a point here. Okay, so you see there is a map, thus there is a canonical map pi from x to x tilde sending x to box x. We may write it class x. Okay, okay, so clearly this is just a set here. Okay, this is just a set. right? We want to introduce
এই শো বলে যে এক্স আইটা দিয়েছো, ক্যাপিটাল এক্স আই কেন দিয়েছো? ওটা মানে স্মল এক্স আই তো হবে না?
no equivalence class বলে দিই। I have said about equivalence classes, the elements of the partition.
আচ্ছা আচ্ছা, ঠিক আছে ঠিক আছে।
Introduce a particular topology on X tilde which has such that one pi becomes continuous the topology tau on X tilde so that pi becomes continuous. 2 tau is the largest topology on X tilde such to make pi. So you see, our goal is not only to make pi continuous, but to make I mean to get a topology on X tilde such that it is the largest topology to make tau continuous. Okay. Can you give me an idea, a natural idea?
We have to make finer. I mean, we have to make the topology finer.
Oh, by large I mean finer, huh? Largest I mean finest. Finest, coarsest. I hope you know that. Continuous economics. These are all those things that comes later. But for the time being, yes. So define tau. So O subset of X tilde is open in X tilde if pi inverse O first tell me whether the definition is clear or not. Is the definition clear? So we are only taking those sets in X tilde whose preimage is open in X. So pi is automatically continuous. Right? So pi is automatically continuous, right?
Yeah.
What about 2?
So we'll take arbitrary topology and that will be contained in
Automatically
this top.
continuous. Let me see whether they have this topology is called the identity within why the space obtained from a single point construction of Mobius strip. Okay, they're writing to those things anymore. Okay, this I will do, but what I'm looking for is something else. Just a minute. not this. Differential geometry, separation and homotopy.
এগুলো সব বইয়ের নোট নাকি মানে ক্লাসের নোট?
This is the note when Jolita taught me.
ও আচ্ছা।
So first of all, let's understand the book Armstrong. Okay. Don't expect it to be a book which will spoon feed you, because it won't. This is not a book that will spoon feed you anything. So you will have to. The book is sort of will challenge you at every moment. Okay, from the theory to the exercises. First, I want to visualize. These two notes we will have to go through. Collective plane is there. I want to cover this before continue Armstrong. Figure open is continuous by definition. So let's do it Bharat notation. Let's not write tau, let's write script f. And then first it is defined to be arbitrary set. Okay. Wait a minute. Let's develop the theory by taking any surjection pi from x to y, where y is any set, and x is a topological space. Then we will see x tilde as a special case. Okay, it will be more elaborated. So you see, so it is defined just the same way, right? Identification topology, Let y be an arbitrary set X topological space. P x to y is a surjection. The identification topology on y is determined by P is script f P. P is the map, so it is like, let's write it P. So they are defining script f to P. I mean, they are helping. They are taking the help of the map P in order to define a topology on Y. Okay. So P inverse U subset of Y such that all those sets are open in Y whose P image is open in X. Okay. So first of all, you have to check this is a topology. Check this because these checks are supposed to be done by you. Okay. Again, this is not a spoon feeding course. You are solving Armstrong, and in a few months you will be moving on to Hatcher. So don't expect me to check whether something is topology or not in the class. Check that this is a topology on Y. Phi p is the largest topology in Y such that P x to Y is continuous. Okay. So this is the proof of it. Okay, you see this proof just. You have 2 minutes. Just go through this proof and go through the definition. You have 2 minutes. this is the definition. Let x and y be two spaces. A continuous surjective P x to y is called an identification map if the topology on y is exactly phi p. Okay. So if we put pi equals to p and y equals to x tilde, we have the identification topology on x. Let me see what Dada is doing here. What is his xy continuous open surjection continuous maps? P x to y is continuous if there is a continuous map. Okay. We will go to this. There is the partition. Construction of a topological space. Okay, so he is developing that later, and then 7, probably in 7. Yes, that's good. That's the way to do it. Okay, let's go. Okay, so first, this is a theorem. Okay, I will send these 3 notes to you. P x to y is a continuous open or closed surjection. Okay, then P is an identification. Okay, by identification you mean, so you see, this is a topological space, y is a topological space, P is an identification map. By that you mean P inverse U open in X, this will imply U open in Y. Understood? Because P is continuous. So if U is open in Y, then P inverse U is open in X. But what about the opposite? Only the opposite, only the converse assures that that P is indeed an identification map and not just a continuous map. So suppose script F is a topology on X, we want to show script F is script FP. Okay. So since P is continuous and script P is the largest topology on P such that P is continuous by definition, so F is contained in FP, right? Now suppose U is in FP. Okay. So from the larger topology, you are picking up an open set U. So P inverse U is open in X, right? By definition. Since P is an open map, P of P inverse U, that is U, is open in F, right? So you see, U belongs to the script F. Now see, I mean, one thing you need to understand. When we say P is an open map, so already Y has been given a particular topology script F. We are trying to show that script F is script FP. So when we are saying that P is an open map, we are saying that P is an open map given given the topology on Y in this. Given the topology on Y is basically script F. Okay. So P inverse U is open in X. Thus P of P inverse U, which is U, is open in script F. So when we are saying the open map, don't confuse that. Don't think that we already have that script FP on Y. I mean, we have it, but we don't know whether they are exactly equal or not, or whether P is open with respect to FP. We don't know that yet. Since P is an open map, so since P is surjective, yeah, this is true because P is surjective. So you have U belongs to script F. that is, it is equal. So any surjective open map and continuous or closed is basically an identification map. Okay, you can do the same thing with closed. Just as we denoted everything, like see, this identification topology was denoted by defined this way, like P inverse U is open in X, only then we call U is open in X. We could do like this: C subset of Y is closed if P inverse C is closed in X. Okay, so that would have given the exact same topology. Okay, because you understand, since this is a surjection, you have P inverse of X minus C is basically nothing but P inverse X minus P inverse C, where P inverse X, sorry, P inverse Y minus C I should write. And since P is a surjection, P inverse Y is X and it is P inverse C. So if P inverse, so closed, this is open in X if and only if P inverse C is closed in X. Okay, so defining it in terms of closed sets will give you the exact same topology. Okay? This construction I have just told you. Okay, now let's do this. This is a very important result, I feel. So the statement says that if P is a continuous map from X to Y and S is a continuous map from Y to X such that P compose S's identity, then P is an identification map. Okay, so first of all, see, P is a map from X to Y, and from Y to X there is a map such that P compose S's identity. Okay, then they are saying that P is an identification map. Okay, that is they are saying that P inverse Y, P inverse U is open in X if and only if U is open in Y. Let's see. Now see, P compose Y, P compose S is identity Y, it is surjective, thus P is surjective. Okay, because you could pick up any Y and you could say that Sy is the pre-image of Y, because if you put P compose Sy, you get Y. Okay, so Sy is the pre-image of Y under P. Now suppose script f is the given topology on Y, then P is contained in this, right? Now again at the same trick, U subset belongs to Fp, P inverse U is open in X because P is continuous, and since S is also continuous, S inverse of P inverse U is also open in Y, right? Now what is S inverse compose P inverse of U? That is nothing but P compose S inverse of U, right? That is open in Y. Now what is P compose S? That was identity. So U is open in Y. Okay. With respect to F, so you see U is inside F, right? So F is equals to Fp. Hence the proof. Now this is the same thing we did. This is the construction that we discussed. With the partition and all that. From here we will go to the next class. Okay, from there we will start to the next class. So remind me to start from there, the page 9 of this algebraic topology video 6. Okay, with down there. So I sort of end this class with a question, that is, so see, in our page 1 we handled a lot of things pictorially. Then all of a sudden we go into partitions and we defined, topology and all that. We defined everything set theoretically. Okay. So if this is your line, okay, and we call it, what should I say? Let's call this line L. Okay. So my question should be this line now. Okay. This line. Okay. What is the connection, or maybe what is the correspondence between things above the line L and things below the line L. Okay. So to answer this, we will first prove these theorems. Okay, all these, and then we will move on to this Mobius strips and all that, and we will show that everything we did pictorially is actually will make those things an identification space. I mean, if this is our X, okay, so we will show that under some, there will be some equivalence class under which if this is X, this is your exterior. 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 So we are about to find in the next class what are those equivalence class relations. Okay. Okay, I'm planning to take this class. I'm really planning to take one or two more classes in quick intervals, because let me tell you my goal. I mean, I want to go through this section as early as possible. Okay. Cone construction is all that. So maybe two more classes. I want to take these things in quick succession. Once it is done, then I will give you a 7-10, maybe a 5 or a 7-day break for the exercise. So we will first do, okay, we will do the exercise, but I will dedicate two classes to solve this exercise. But I will give you 2 weeks to try this. Okay. So maybe first 6 problems I will tell you exactly which problems to try. Then in the next and then 7 days later I will check them, and then the same in the corresponding week. The next week. So I'm trying to take these classes in quick succession. Let me see. রাহুল একটু মনে করাস তো?
মানে এক সপ্তাহের মধ্যেই করতে চাইছো?
আমি এক সপ্তাহের মধ্যে আরো 2টো ক্লাস নিয়ে নিতে চাইছি।